and this is Rich, and it's been a while since I did a tutorial. I think it's been like a week or so since I did my tutorial last. That's because I've been very busy with C++ actually. Before I said that I wasn't a programmer, I've spent a lot of time, especially recently, figuring out how to program in C++, and then apply that knowledge to Cryengine. So I think I've gotten a good basis on how Cryengine works in terms of C++. Still, obviously, it'll take me many months to understand fully how Cryengine uses their code base. But to everyone's surprise, today is a tutorial on programming in C++ with Cryengine. This is not going to be how to change a simple cvar or how to start up Visual Studio. This is actually going to be programming in C++ with Cryengine. It's going to go over how to start up Visual Studio, how to set up Visual Studio, how to add your own custom C++ files or .cpp and .h files, how to write your own functions that can be used with Cryengine, how to call your own functions that are written in your separate .cpp files, where to start putting your code, different source files that Cryengine has that are important to be looking at. We're going to go over where the game loop is, where all of your code is going to be placed, where the game starts in terms of C++ files, and this is going to be a huge eye-opener for a lot of people out there. I've seen people over and over say C++ tutorials, C++ tutorials, C++ tutorials for a long time. I was one of them people for that. Obviously, after many months, probably a couple of years since the Cryengine has been out, for the mods, many years, people are asking C++, and we really haven't gotten any. There is a reason for that, obviously. Nobody knows how to do the C++. I mean, they may know how to do simple things, little things, but obviously aren't willing to share. So I had enough of that because I'm making an RTS game, as you guys know, and you do need C++ knowledge in order to do that. I mean, in order to implement your own RTS game, you're going to need to know C++ because you're going to need to change some core gameplay mechanics in there. So I've gone ahead and said, screw it, I'm not going to wait for somebody to do a tutorial on it. I'm going to try my hardest, and for the past few weeks, I've been hours and hours, days and days at a time. The past 3 nights in a row, I haven't even slept. I got like 5 hours of sleep in the past 3 days because I've been studying Cryengine's code. I was in Visual Studio just looking at Cryengine's code, and I kept trying to figure out what the hell was going on. Well, I finally got a little bit of a basis and understand a little bit of how to get started, and that's what the tutorial is going to be today. Specifically, this is a RTS, part of my how to make an RTS game from start to finish. This is part of that tutorial series, and it's going to be about adding your own camera through C++ with your own source files. It sounds like, oh, not very important. But actually, Flowgraph only offers so much in terms of camera. And even with Flowgraph, every different level that you have, you're going to need to re-implement your Flowgraph because it's a per level basis. Well, C++, you can sit there and write your code once, and then it implements over all levels. I mean, it's on a per level basis, so it's very important. So that's why I realized that, okay, I need to do this camera through C++ and not through Flowgraph, even though it's possible through Flowgraph. It's just a lot of work. So let's get started. Alright, first of all, we're going to open the Visual Studio 2010. This is the Express version because I'm a cheap ass. Don't have enough money for the professional. Visual Studio C++ 2010. Once that's opened, we're going to go directly to File, Open, Project Solution. Then we're going to go to our Cryengine root directory. I was just checking to see if I was actually recording, because I didn't want to be recording. Didn't want to be recording and oh, sorry, didn't want to be not recording and talking like this. But yeah, it's recording here, so that's good. Alright, Cryengine root directory. Then go to the code folder. Then you're going to go to the solutions folder, and you're going to see Cryengine game code only. Go ahead and double click on that. And just wait a couple of seconds. This is the newest version, the 3.3.9. It's going to give you some errors. One or more of the projects in solution are not loaded. Just click OK. As you can see down here in the output window, we have warning. Platform Xbox 360 reference in the project Cryengine cannot be found. This is perfectly fine. Obviously, we don't have Xbox 360 code, so that's fine. Now that we've got Cryengine opened, the Cryengine solution opened, we can start programming our game. So let's just go over here. This is a Solution Explorer, and this is going to assume that you have some prior knowledge of C++ in general and Visual Studio. Now, the tutorial is basically about scripting with Cryengine. So we have Cryengine, Crycommon, and RTS game. This would normally be Cryengame. I just changed the name here, and when you change the name here, it outputs a custom file. Usually be crygame.dll in your bin32 or bin64 folders. By changing the name to RTS game, it just makes it more custom for me. It's just something that, it's an RTS game, so I just changed it to RTS game. And it outputs a rtsgame.dll instead of the crygame. But obviously, Cryengine's configured by default to load crygame.dll as your game. So there's a script file that you have to change to tell it to load your rtsgame.dll, and we're going to go over that. I'm just letting you know why this is RTS game when yours will say crygame. By default, opening Cryengine, you may Cryengine solution file in Visual Studios, you may encounter some more errors that pop up at the beginning, as in Crycommon, which is right here, may be grayed out or unavailable, and then be in another one called game, and it may be grayed out and unavailable. For one, you do not, for sure, want to build Crycommon. Crycommon is already pre-built when it comes with Cryengine. You do not build or compile Crycommon at all. This Crycommon needs to be non-compiled. It needs to be in its original default. You can, however, go ahead and do Cryengine and then obviously your game DLL, which in this case is Crygame or RTS game or whatever you want to put for your name here. So this needs to be compiled. All code inside of your Crygame, or in my case RTS game, is the code that you modify for your game. This is the game DLL. All these codes is what you modify. You don't modify stuff in Cryengine or Crycommon, but you cannot build, or you should not build Crycommon, and technically Cryengine as well. You shouldn't build those. But by default, the project is configured to build Cryengine and Crygame. So what you want to do first, once you open this up, you're probably going to have cannot be loaded on both. You're going to right click on Crycommon, which in your case will be grayed out, and then you're going to click on remove. And then you want to click yes, you want to remove it. You're going to do the same thing with game. You're going to right click on that game project, and you're going to remove it. Once that's done, you're going to right click on your solution, go to add existing product, and then you're going to re-add in Crycommon. The game that you removed doesn't even have anything to do with this, so you can just keep that out. But you want to reload Crycommon. So after that, you go to Cryengine root directory, code, right? bin32, bin64, code, Cryengine, Crycommon, and then load up your Crycommon again. After you've done that, you're going to have exactly what I have. Cryengine, Crycommon, Crygame. My case, RTS game. Crycommon and Cryengine are already header files that Cryengine included with the Cryengine build. These are basically functions that you have access to, things that, functionality that you have access to. So in your game DLL, in this case it's RTS game or Crygame, is where you would say, okay, I want to use some of the functions that Cryengine already had in their Cryengine or Crycommon. So you go ahead in RTS game, you write your C++ file, your CPP file, and write some functions that are maybe defined inside of Cryengine or Crycommon. And that's what I have done. Actually, I don't even think I used any of the header files that are inside of Crycommon and Cryengine for my implementation or for what we're doing today. But that's how you set up initially Visual Studio. You get rid of those two that are grayed out, that said they're not available, and then you just reload Crycommon. You're going to have this. After that, you're going to want to right-click on RTS Game to set some of the properties. And this is, again, configuring Visual Studio to work with your project. This is just the configuration stage. Once we do that, you right-clicked on RTS Game and went to its properties. You're going to have active, which is your debug, and active 64. I'm building and running in debug. 64-bit is what I compile and run in. So, under configuration properties general, this is asking the output directory, saying, after we compile RTS game, where do we want to put it, and what file type is it going to be? So, where are we going to put it? Well, go ahead on output directory. Where are we going to put this compiled version, this DLL? Go to Browse, root Cryengine directory, bin64. Because we're building this 64-bit version of our game, we're going to put it in the root directory bin64. There we go. So now and now it's going to ask target name. This is the name of the file that it's going to output once it compiles, and this is project name. This means that when this is compiled, this RTS game is compiled, it's going to be called RTS game. Now target extension .dll. This means that it's going to be when it's compiled, it's going to put it in a folder, which is your bin64 folder, right? And it's going to be named RTS game, the exact name of your project, right here, project name, and it's going to be a .dll. So it's going to be total RTS game.dll located into the bin64 directory, where all of your binary files are located for running Cryengine. That's all you have to do here. Change the output directory, target name, and then target DLL. A target extension DLL. Then we're going to go into the debugging tab. And obviously you can't run, well, not obviously, this is why I'm doing the tutorial, but if you go and push on start debugging, you want to load up your game to see, okay, what changes? How did I do all my changes? You can't do it. Why? Because it doesn't know what file to open to test your game. So under debugging, you're going to want to go to the command. In this command, what this is what file do you want to load in order to debug your game? Well, doesn't Cryengine use the launcher.exe to load your game, the Cryengine game? It does. So you got it right. Command, we're going to open up the command, go to browse, and we're going to browse to the file we want Visual Studio to open so that we can debug our game. And that is located in our Cryengine root directory, bin64, launcher. You could choose editor if you want to, but since you're, testing for pure game, because in Cryengine, some things don't take really effect in editor. Some things are not supposed to run inside of the editor because it's just an editor. And pure game mode is basically how you truly test if your code is perfect or not. And that's why we're running the launcher, which is the pure game mode. Editor, which is just the editor, testing and stuff. Launcher is pure game mode, so you want to run the pure game mode. And that's 100% perfect. That's all you have to do to configure Cryengine with Visual Studio C++, and we can actually get into the scripting. So why don't we get started, right? Okay, so in our RTS game, remember, whenever I say RTS game for this project here, it's in yours, it will be Cryengine. Or if you have an old version of, Cryengine, it will be game DLL, I believe. Here, let's close all these directories here. So in our RTS game, we have a bunch of CPP files and .h files, which is .h is a header file, .cpp is a source file that gets compiled, and we'll go over that a little bit in the future. But right now, all the actor files are located inside the actor folder here, right? all the audio, and then voids and cameras and editor game files, your game files, okay? But what we're going to be looking at now is inside of game files here, you're going to have a whole bunch of C++ files or source files and header files. And we're going to be modifying, I think we modified the game. Yep. We modified this file here that we're going to go over. We're going to be changing stuff in the game.cpp. Okay. Another file that we're going to be looking into for modding, for writing our game is going to be, where are you? Startup files in the RTS game project. We have startup files, and these are very important. These are the files that are initially run. As soon as you click on the launcher game, which is the launcher.exe, as soon as you click that, in order to start its game, it runs these game DLL and game startup files. These are one of the first files that are read for your game. So any initialization or startup code you want to write, you'd put it in these three files: game.dll.cpp, game startup.cpp. Okay, so let's take a look at game startup and game DLL. I just opened them both up so that I can view them up here. For me, this is a little bit sophisticated. Some of this I don't understand here. Just basically, you won't really need game DLL, especially for this project here. We may go over it in the future as soon as I get more advanced. But just know that this game DLL here, what it does is it is in control of loading the file, okay, the .cpp file, that is going to be your game, where your actual game is going to be located. Game startup here is just taking care of all of the initialization for the game interfaces. Okay? We're not going to be touching these whatsoever in this tutorial, but just know that those are the first files that are loaded. Okay. So, here's the deal. Since this is going to be about loading a camera, okay? Just give me a second here. I know that this line of code that I wrote does not work right here, so I'm going to comment it out. I don't know why it doesn't work. It just gets me really pissed off. It just does something really weird. But let me go ahead and show you what I'm talking about. Let me just run my code to show you what the result is. It's not pretty, mind you, but it is done in C++. So I just clicked on the play button here, and it's go ahead and launching my launcher.exe. So I'm waiting here. It's just building my code right now, and then it's going to launch the launcher. Debugging information for launcher. That's fine. Yep, I want to continue debugging. It's not needed. Just going to wait. And as I do more C++ tutorials, you'll notice that I'll get more fluent in my speech. I'll get a little bit more clear and be a little bit more organized. To be quite honest with you. I'm doing this to help out the community. Also, this will be the first C++ and Cryengine video tutorial on the internet. You will not find another C++ tutorial in Cryengine as advanced as what I'm doing here, or even at all on Cryengine C++. And I do want to be, I pride myself on it, the first person to do this. So yeah, there's a little bit of my ego in there, and you know, me want to be the first person, because you know, I do these tutorials to help the community, but it also helps me out a lot too. It gives me, I take pride in my work, and being the first one to do this is you know, it means a lot to me. So go ahead, and once we're done, just log in. Even with the launcher, you still have to log in, which is dumb. because as soon as I, let's say I don't have enough money to pay for my internet, I can't use Cryengine anymore. No internet, no Cryengine, which I think is stupid. But go ahead. Crap. If I remember correctly, my video recorder does not record screen if it's in full screen. So if I'm correct, you guys won't be able to see anything. You'll see a black screen. So let me try to fix that. Graphic settings, full screen, no. And let's just bring down the resolution. Sorry about that. I think I think you guys should be able to see now. I don't know, but from past experiences, I think I remember that it doesn't show my screen if this game, Cryengine's in full screen. So I think you guys will be able to see. I'm 100% positive actually now. So once we started, it just loaded up here. We're going to go to single player, and I'm going to load up my little tiny little map here. It doesn't really matter because it's going to the camera's going to be in the ocean. But go ahead and click on it. It's going to load. As you can see, my camera, I have a custom view, and my camera is located in the ocean. Actually, my camera position is 1, 1, 1. 1 meter in the x-axis, 1 meter in the y-axis, 1 meter in the z-axis. It's 1, 1, 1. I haven't told it where to put my camera. But we do have a custom camera view. We don't have the player here. And that's how we implement our new view. So let's go ahead and close out. And let me show you what in this unhandled exception. That's fine. Again, I'm still in my debugging stages here on getting my code perfect. I just wanted to rush this out so that I can, like I said, be the first person to do it. So let's go back and let me just get rid of my functions here to show you what happens when you don't have my custom code in Cryengine. I know that I can, if you guys are familiar with C++, I am aware that I could use a comment that goes from one point to another, but I'm just using these single line comments. I know there's a faster way of doing it, so, but I'm just doing that here. I'm going to block out all of my code, okay, and I'm going to run again. Actually, let me get rid of my function definitions as well. I think I'll get a compiler error if I don't. So let me just run again. And yep. And that's not an issue. I am aware of this. Just give me a second to comment out my functions. And let me just reload it again. Cool beans. Let's go ahead and start. Again, it's just got done compiling my code, and now it's launching at launcher.exe because we told it to in the properties launch the launcher.exe in the command field. And again, you guys won't be able to see my freaking screen. I don't know why it does this. think you guys should be able to see it now. So go to single player. I'm going to load the same map. I have parallax occlusion mapping on the terrain here, and it's very basic, very, very basic. But apparently it's not loading my parallax occlusion mapping unless I go in the editor and reset my settings, which is stupid. I think somebody else had an issue with that on Crydev, and I helped them with it, actually, and now I'm having the same issues. Isn't that ironic? So now I'm actually the player here, and you can see here, I'm the player, and this is like the regular standard view. See? Regular standard view. There we go, no camera, because I commented out my code. Pretty cool, if you ask me. Pretty cool. So let me go ahead and uncomment out my code. There we go. Yeah, I'll leave that commented. It'll mess it up. And let me just uncomment my function declarations. And let me right click on my solution and build, so I can build my solution again, because if you make changes you have to build it. But I don't want to run the editor. That's why I didn't click play. If you click play, it compiles it and then runs it. If you just right click on the solution and then click build, it just builds it without running it, which is what I want to do. Okay, everything is done. So let's go over how to add your own CPP files and .h files, which is your own custom code in your own files. So under the RTS game, you can do a couple of things. You can right-click on the RTS game project, right, and then you can go to Add, and then New Item. And when you go to New Item, see, you can add a CPP file and a .h file. So if you go to CPP file, click on it, and then write blah 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 blah, whatever you want to name your CPP file, and then click Add. It's going to add a source file that's a .cpp in your project. And if you want to add a .h file, do the same exact thing. See, blah 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 .h, blah 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 .cpp. I'm going to cancel out of that. Okay, or you can just go into one of these folders here and do the same exact thing. Add new item. You can place your code wherever you want. Just make sure that it's in the RTS game project or the Cryengine project or whatever yours happens to be called. But I didn't do any of that. I made my own folder here, which is my files. That way I can keep track of all my custom files, and I know it's my files here. How you do that is you go ahead and you click on the RTS game, and then you add new filter. And you add a new filter, see, it puts a new folder here, and you can name it whatever you want. Blah 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 blah. Enter. And then you can right click on that, add new filter to make another folder inside of that. But I don't need this anyways, I've already done it, so I'm going to delete. Just like that. So I'm going to go to my files, added the filter, add another filter called cameras, because all my cameras are going to be in here. Different types of cameras. Currently I only have an RTS camera, so I made a folder in that called RTS camera, and then I made my own RTS camera.cpp and RTS camera.h, two of the same named files. .cpp, which is where my code is held, and a .h, where my definitions are held. You can put definitions and functions, doesn't matter if you put in a .h or .cpp, but the typical convention is to put your definitions for your functions and stuff like that and in a CPP file, and a .h is the declaration and your class declarations and stuff like that in a .h file. So I've done that. I made 2 files. So on my RTS camera, I right-clicked, added, new item, and remember I chose .cpp and .h, and I named them accordingly. So what we got so far is we talked about how to set up Visual Studio with Cryengine, naming your project here to whatever you want. You can just name it by clicking, left-clicking again. You can change your name. So you can go like this, change it to wherever you want. Remember, when you change this name here, right after you do that, it's not going to run your files, actually. It won't run. It will run Cryengine because it uses the already existing Cryengame DLL that's in that directory, but in order to use all your changes after you've changed the name, you do have to do one step. And we will go over how unloading your own custom DLL that has a different name than Cryengame. We'll go over that eventually in this tutorial here. So we talk about adding filters, which is your own folders, which are more for organization, and how to add a .cpp file. So if you compile this, you can see it works fine. Nothing will be different because you say, hey, we changed the code. We didn't. We just added a couple files. So it'll be exactly the same because all you did was add files. So now let's go ahead and write some functions in our custom files. Okay? So let's open up our .h file, which is where we declare, okay, where we declare functions that we're going to be using. And on top of the line, this is 1. This is the beginning of the file. All that's in it is void, create, camera, and a colon. Bool is level loaded, and then some parameters, and then a comma. This is the declaration. This doesn't do anything. All it's doing is telling Visual Studio in our code that we're going to have a function sometime in our program called isLevelLoaded and Cryengine RTS camera. Now these aren't existing functions with Cryengine. These are our own functions that we're going to define what they do. That's the whole point of C++, is making your own functions, So I made a function here, create RTS camera, and I made a function isLevelLoaded with a couple of parameters. Just letting it know that, hey, we're going to use these functions later on. How you do that for a declaration, the difference between a declaration and a definition. A declaration doesn't contain any code as in what the function does. All it says is the name of the function, the return type, and then a colon. Ready? The return type, void, name of the function, right there, with these 2 opening, closing, right? And then a comma. That's a declaration. A declaration, again, says we are going to have a function named this, and this is its return type. That's a declaration. See, it doesn't have any code on, in between here saying this is what it does. That's a definition. A declaration says we're going to be using a function with a return type of void. The name of it is called. The name of it is called create RTS camera, and that's it. We're going to have a function named isLevelLoaded, and the return type is going to be bool. That's a declaration. Simple as that. Now, that's in a .h file. Remember I said declarations are in .h files? Let's go to the .cpp file. Here we go. Now, this is a definition. A definition is what the function does. So again, we have the return type here, right? Void. We have the name of the function, right? Create RTS camera. And we don't have a colon. That's because we're not declaring the function. No colon if you're going to define. If you're going to declare by saying we're going to have a function named this and this is a return type, you do need a colon. When you go ahead and define what that function does, see, all this is what it does, you don't need that colon. So we have the return type, create RTS camera, and then we have an opening curly bracket and then a closing curly bracket. This means the start of what the function does, and the closing means this is the end of what that function does. So let's go over this one more time so I can be very clear. In the .h file, we're saying, hey, we're going to have a function named this, and this is going to be its return type with a colon. We're done. In the .cpp, you have to name it exactly the same. as what you declared it as. But on the definition, which is in the .cpp file, what the function does, okay, is this with a opening and closing curly brackets. So we said that we're gonna have a function that does that, and we do. The function right here does this. There we go. So that's what a function is all about. Declaring that you're gonna have a function named such and such, and then defining the function, saying this is what the function does. All right? Simple, simple, simple. Again, these are our own functions that we're defining. They're not pre-existing. These are something we've completely created from scratch. So somewhere along the line, I've decided that I want to create an RTS camera. I want to create a camera that has my own parameters that are such like an RTS camera would. So I said, okay, I'll make a function that makes a camera. So that's how I ended up with a function called create RTS camera. I logically decided that if I want to create a camera, why not put it in a function that is called create RTS camera. That's why I named it that. And then I created a function called isLevelLoaded, because I want to be able to create the camera when the level is loaded. When the level's done loading, go ahead and create that camera. So that's why I named this function isLevelLoaded. And you guess what it does? It checks if the level is loaded. So let's go ahead and start programming what our function does. So here we go. Okay. I put notes here. A note. Find our camera entity in the game named GameCamera, because without it, it will crash. So this is a pre-existing Cryengine function. See, I have a Cryengine function that's already existing, that Cryengine already has, inside of my own function. And this function here, it looks for a entity that's in my game world. Okay, and this is iEntity, a pointer called pEntity, equals global environment, pointing to another pointer called system, and that pointer calls a function named getIEntitySystem, and this function here returns, okay, we'll talk about that later, returns the entity system. And then entity system calls a function named findEntityByName. And then the parameter is the name of the entity you want to find. And then this function returns, again we'll talk about that later, the entity that is named CryCamera. And then we have the equal signs because it stores that entity, right, into a pointer called pEntity. So whenever we want to refer to our entity, we're going to talk about our camera entity, we're going to refer to it as pEntity from now on. So if I want to get the rotation of my entity, right, this camera entity that I found, I will refer to this as the entity, right? So in Lua, you'd say, you know, something like self, right, self dot get rotation to get the rotation. Well, in this, you do something like pEntity, as in pEntity is now self, because pEntity represents our entity, because we assigned, see, equals, we assigned our game camera, right, the entity, into a pointer. This is all going to be explained later. This is just basics, okay? So pEntity. So if we want to get the rotation, it'd be something like, actually, let's just go ahead on this next line. Type in pEntity, right? And then you can see all the functions that this entity is able to have. You can activate the entity, add entity length, add flags, attach a child, right? Check flags, all of these here. See, we can get the entity's class, we can get its child, right? We can get the character, get AI, right? This is an entity. This pEntity pointer that we made, right? We assigned that entity to it. So right now we have all of the functions that an entity has, just like in Lua. See, get position, right here. See the description? Retrieves the entity local space position. Cool. Get proxy, we can get its rotation. Get scale. Simple. Why can we call these functions? Because we assigned, right, our entity. First of all, we got an entity. We got an entity named game camera, and that returned the entity. It gave us the entity, and then it assigned it, boop, to our p entity pointer. So this pointer is talking about the entity. So this is the entity, p entity, right? And now we can access its functions. Just as simple as that. This is all going to be explained more in detail, but I'm just showing you basics right now. And then this creates a pointer to the iViewSystem interface named pViewSystem. So on the iViewSystem type or struct class, we're creating a pointer, pViewSystem. But what is it going to equal? Global environment is calling the pGame pointer, and that pGame pointer is calling a function getIGameFramework, and then it's a function, so it returns a value. It's returning the game framework. It's getting the game framework. Now it's going to return game framework. So the game framework is going to call a function getIViewSystem, and this iViewSystem is a function. It returns the iViewSystem. So the iViewSystem is going to equal pViewSystem. See? So whenever we're referring to pViewSystem, we're talking about the view system. Okay? So whenever we say pViewSystem, we're talking about the iViewSystem. So let me just tell you this. So if I go ahead and use p, because we just assigned the view system to our pointer view system, so whenever we want to access a function that's in the view system, we do pViewSystem. So let's go type in pViewSystem. Okay? And let's see the functions. We can add a listener, right? We can create a view. We do that. We actually access this function in the next line to create a view. Get active view. You can get the active view. We can get the active view ID. We can get a view. We can get view by entity ID. We can get view ID. We can check, are we playing a cutscene? See, this is the view system, the pViewSystem right here. The pViewSystem, right, holds, see, the pointer points to the view system. So now, if you want to access the functions in the view system, we just use pViewSystem dash greater than symbol. And it'll give us all of the functions that the view system has. Serialize, set active view. We use this function in a few minutes. So let's go ahead. We're going to go over all these pointers actually. These are called pointers. This little thing right here, little multiplication symbol, then this is a pointer. Okay? So this one here creates a view and then stores it in our pointer named pView. So we have a type of iView, right? This is a type. Type iView, right? Pointer pView equals pViewSystem create system, create view. So again, what does pViewSystem equal? Well, pViewSystem points, right? Remember, pViewSystem points to the view system. So in order to call a function that's located in the view system, we use pViewSystem create view. In the create view, what it does is it does the function, it creates the view, and then it returns. What does it return? It returns the view, not the ID or not the name. It just returns a type of view. And that is stored in pView. See? Equals. So the pointer pView of type iView, okay, points to our new view that we created. Simple, right? So our pointer pView points to our new view. Just like that. And this is get the ID of our new view, because we can't really refer to that specific view unless we have some way of identifying the view. So we do that right now. So we have an unsigned int, which is a type. See, this is an int type, right? Int. This is a iView type. This is an iViewSystem type. And this is an iEntity type. Because let me go over this real quick. This find entity by name, if you just hover over it, find entity by name. If you can see the code hints down there, the first line you see is I entity. That's because it's of type I entity. So since we have the equals signs here, right, we need to have an I entity variable, which is right here, P entity. We need to have an I entity variable to store an I entity value. See the I entity? See, I entity on the code hints is a type, right? It's a type. It returns a type of I entity. So just like in regular C++, you know, int, right? Int happy, right? Int happy. We created a variable called happy of type int, right? And let's create a bool. Actually, no, let's create a string. See, a string variable, right? String variable called nice. Okay? So now we have two variables. We have a happy, which is an int, and we have nice, which is a string variable. So you know, C++, if you say this, happy, right? Happy equals nice, right? All you C++ guys out there, you know that this cannot happen. You cannot assign, see equals, you cannot assign a string type to an int type. Why? Because string is this. A string is this. Ready? The cat went to the store. That's a string. A string holds words, just like that. A string holds words. And what does an int hold? Numbers. Right? 1, 2, 3, 4. So how can you sign the cat went to the store into 1, 2, 3, 4? You can't, because this is of string type and this is of int type. You can't store a string variable into a number variable. It just doesn't work. Same thing goes here. Cryengine created a struct, see, code hint, struct iEntity, which is a type. It's a type. iEntity is a type, just like int is a type, just like string is a type. iEntity is a type. So we're creating a variable called pEntity, okay, which is also a pointer. We're creating a variable called pEntity of type entity. And we have an equal signs here. So this is a whole function here. And like I said, what this function does, global environment, right, calls the P system, then the P system calls the get iEntity system, and then the iEntity system calls the find entity by name function. And it finds our game camera, and then this find entity by name returns the entity, which name is game camera. It returns the entity. If you hover over this, it's an iEntity, the code hints, iEntity type. So, in order to store an iEntity type, we have to put it into an iEntity variable. That's why we have iEntity. Same thing here. iViewSystem. It's just like an int, just like a string, just like a bool. It's a type. iViewSystem is a type. And get iViewSystem, look at the code hints. iViewSystem. That's the type. This returns type iViewSystem. So we need to store it in a variable called pViewSystem of type iViewSystem. That's what all these view systems here are. See, and I figured you guys would be a little confused on what this means. I was confused. So what this is iViewSystem is a type. We're creating a variable called pViewSystem. That's right, we're creating a variable called pView of type iView. And then pView, right, of type iView is going to equal our new view. It's going to point to our new view because it's also a pointer. So it's going to equal our new view. And what does our view create view return? It returns an iView variable. That's why we have here. So it's not confusing at all. If you don't know, how Cryengine does their code, you'll think it's very confusing, and that's why I had so much trouble, because I couldn't understand what the hell they were talking about. So I just want to make that very clear, and that's why I'm going over the board with this, because it's very important that you understand, because this can get very confusing really fast. Very, very confusing really fast. That's why I'm going over it. So I'm creating a variable, much like int happy, string nice. Okay? I'm creating a variable called pEntity, of type iEntity, and that's going to equal the return value of this function. See, this is all one function right here. That's all just a long, convoluted function. It seems long, and you don't know what it's doing. All it's doing is this one here is calling this, and this is calling this. This is calling this. But all it's really doing is calling the findEntityByName function. That's really the only function that's being called, and that is what's being assigned to the pEntity variable. That's all. It's just in order to find this function, right, you need to get where it's from. And it's from the global environment, pSystem, getIEntitySystem, findEntityByName. That's all it's doing. All of this is just where this function is located. Just wanted to let you guys know that. So let's continue. This unsigned int view ID right here is an integer. A little bit easy to understand because it's not an iView or an iView system or an iEntity, which is in C++. Those don't even exist. Cryengine made them. That's why people are like, oh, what the heck is this? People know what int is. I mean, that's all around. Int is int, right? So that's a little bit easier to understand. Int. So int view ID, because see, we're getting the ID of our new view. Right here, we created it, and we stored that view in a variable called pView. But we don't know how to access. We can't access that view unless we know about it. So let's create a variable that talks about what its identification is. View ID. Just like entity ID, we're getting the view ID. So instead of an entity ID, we're getting the view ID. So we're creating an int, right, called view ID. So we're creating a variable called view ID of type integer. Oh, unsigned int, by the way, if you guys don't know, it's same thing as an int. It could be a negative number here. It could be a negative number. By adding unsigned, int can be a negative number. So view ID equals pViewSystem get view ID, and the parameter is pView. What ID? See, you get ID function, and this is what ID we want to get. What is the entity ID that we want to get? pView. See? Because we assigned the variable pView to our new view. So whenever we use pView, we're talking about our view, our new view we created. So we want to get the view ID of our pView, our new ID. And then we're going to store that into our variable called view ID. Simple, right? So now when we talk about, we're referencing view ID, it's the entity ID of our view. Very simple. This right here, set our new view to the active one, because now we created a view, but now we want to set it to the one we're actually going to view out of. Because if we don't make our view active, it'll just be there in the background somewhere, and you won't be able to see through it. It won't be your current camera. It'll just be somewhere not being in use. So we have to set it to the active one. pViewSystem, right? Because remember, what is this pViewSystem variable? What is that? If you remember up here, our pViewSystem talks about the view system. It references the view system. So we want to use the view system to call a function that's inside of the view system. See? Set active view. View ID. See? Set active view is a function, right, that belongs, that is inside of the pView system, or the view system. So in order to use this set active view function, we need to know where it's coming from, and that's what this is. The set active view is located inside the view system. That's why we need this pView system here. Set active view. And this parameter here that's inside of these opening and closing parentheses is what is the active view. What is it? View ID. So set active view. If you look at the code hints, right? Set active view, and then it takes unsigned int view ID or the view. So with the set active view function, you can either put in the entity ID of the view that you want to set as active, or you can just put in the view itself. So let me put it this way. pView, right, is the view, pView is a variable that references the view. View ID references the entity ID of the view. So in the set active view function, we put in the entity ID of that view to set that view as active. But you could also put pview. Let's go ahead and put pview, oops, capital V I E W. Now if you look, no errors. There's no underlying red stuff. It's no errors. That's because it's valid. So on the set active view function, you can use the view itself, which in our case pview right here is the variable that points to our view. So we can use that. Or we can use the entity ID of the view, which is view ID. So there we go. You put P, but I just put VIEW view ID. Just like that. This last line links the view to our entity so that the view can take all of the transforms of our entity. Unfortunately, this code bit here that I made works half. And I say it works half for a reason. It does assign, instead of the view being in the water, it actually puts it where my entity that I want to link it to is. But the problem with that is the view is weird. I can't see the world. All I see is black and white lines going all over the place. So I don't even know what the hell that, why that does that. Just like that. So very simple. Now that I've explained all of this in basic detail, let's go over exactly. Let's not worry about this function right here. This is not needed. Right here. This is not needed. Okay? So let's go over this. So at first, in my .h file my custom .h file that I created, I just declared, hey, we're going to have a function named createRTSCamera, and it's going to be of type void. In our CPP version, which is our actual compiled code that's going to be used, it's going to be the defining. What does the function do? This says we're going to have a function named this, and this is the type. And this says this is what the function does. And it needs to have the same exact thing. Void and create camera type. Create RTS camera. Void, create RTS camera. Void, create RTS camera. And then the opening and closing curly brackets and everything that's inside here says this is what the function does. Now, if I compile my code right now, nothing would still happen. Obviously, you can build it, but if I want to run it and think that, hey, my code's going to run cool, that's not true. And the reason why is because you declared a function, then you define what the function does, but that's all you did. You didn't tell it to do this function. You said we're going to have a function named this, and this is going to be its return type. And you define the function as this is what the function does, but you never told it to do the function. And this is where we have to do something called calling a function. You're calling a function. Calling means you're going to find that function and do it. So let's go ahead and do that. Remember I told you that there's a main file that you're going to be looking at quite a bit. So go to your RTS game files, right? You're going to look down, you're going to see game.cpp. Go ahead and double click it. Game.cpp. This is something you guys are going to be very, well, first of all, this is going to be important for you guys. This game.cpp is your main file. This is where you put all of your calls, all of your code. This is the main place where you write your code and call functions. In this game file, right, if we go to the C game, see this little drop down box here, we're going to go to the C game namespace, and we're going to look over here at all the functions that it has. This game has a function called check reload level, complete initialization, game channel destroyed, get bullet time. These are all the functions that it has. The main important function in it, the initialization function right here in it, shut down and update. These are the main files. I can't believe it was right before my eyes and I didn't understand where to put my code. So let's click on it to bring us right to the update function. See, update. This update function does a lot of stuff. If you see, hover over it, it does a lot of stuff, and it ends here. So what does this update function does? It means as soon as you start the game, it's going to run this function over and over and over and over and over and over and over again. Every single frame of the game. Every single frame, it's going to run this update function over and over and over again. So if you know that this function gets called every single time the game runs and is on, then it's pretty logical that you want to put your code in here to make sure that your code gets run. Because if this function is run every single frame and your code is in it, you can guarantee your code's going to be read. So that's what I did. It's exactly what I did. So at the bottom of the update function of the game, this game represents the game. This game.cpp file, just think of it, it is the game. This is everything that happens inside of the game. And this update function happens every single time the frame goes. Every frame, it does this function. So at the very bottom, before return, this return here, because if you put code after this return keyword, your code won't run. Because return means stop. Don't execute anything after that return. So you got to put it right before the return. Just like that. And just like that. And let me just uncomment my code. Boom, 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 boom. We're not going to be talking about this isLoaded function today in this tutorial, so I'm getting rid of it. So just ignore all these commented out. So at the end of the update function, I tell it, call my function. So now we have 3 different things involving functions, and let me explain them. In our RTS camera.h, we declare. Remember, we're saying that we have a function with the return type of void. Then our RTS camera.cpp, and these are custom files, remember, that we're making our own custom files, our own custom functions. It's cool, right? So in the .cpp version, we're doing the defining. We're going to still be void, create RTS camera, and this is what it does. And now, in the game.cpp, when the game updates every single frame, we're going to call our function. Okay? We're going to call our function. And what function are we calling? Our create RTS camera. And this is what calling is done. You put the name of the function, just like that, and then a semicolon. That's how you call a function. That's how you say, hey, do this function. Do a function called create RTS camera. So as soon as the update function, it goes, it hits this, it's going to call. It's going to say, hey, do the create RTS camera function. So that it's going to do everything that's inside here, because this is what defines your function. So you're going to say, hey, do this function. It's going to do everything back in here. Once it's done doing this, it's going to, okay, we're done. Now go ahead and continue. So when it comes down to here on the update, it's going to call your function. And calling functions, you don't put the return type. In the declaring, you put the return type. In the defining, you do the return type. When you call, you do not put the return type. You cannot have that there. If you do have it there, your code will not run. No return type. All you need is a name and the parameters if it has any, and then the semicolon. So after it gets here, it goes ahead, calls your function, and what does this do? Well, it creates our camera. That's what it does. After it's done, it goes back to where it began, and then continues the code. See? So basically, when you call a function, it basically stops the rest of the program to do your function. After it does your function, it comes back to right after, and then it continues. When it hits another function, it does that function. Then the code stops, and then it keeps going. Then when it hits another function, it does that function, then comes back, and then it keeps going. Just like that. Pretty cool. So now we created our own custom code, our own functions, our own variables, which are pointers, and then we found out how to call our custom functions. Pretty cool now. So since we have this here, let's go ahead and run it. We may get an error here, and not an error, but we may get a crash. I'm not sure, but we may, because this code was here for a reason. This stuff I commented out. So let's go to login. I don't think you guys can see, so let me go to my graphic settings. Bam, 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 change all this stuff. Really wish my recorder didn't do that. So let's go ahead. Single player, let's load up our map. Nope, no error. But look at that. We have our own custom camera. Of course, it's in the water because we haven't told it where to put it. But still, we have our own custom camera view. We just created our own freaking camera. How cool is that? So let's really go over how this actually works. Okay? Because basically I told you that this is this because, but you know me, I don't like to settle with just do this because. You know what I'm saying? You don't learn that way. You learn by me explaining something, okay? And then me showing you why it works. Why do this? Okay? Because if I told you just do this, then when you try to do something, all you'll know how to do is what I did, not what you want to do. If I just told you, hey, do what I do, then you won't be able to do anything on your own. You'll be able to do what I do, and that's not the point. The point is being able to create your own masterpieces, your own creations, your own ideas. Not just copy what I did. You won't get anywhere. You'll spend hours and hours, days and days, years and years sitting there just doing what other people do and not what you really want to do. So let's go over why I called all of this garbage. You know what I'm saying? Why did I call all of this? Let's go over it. Alright? Give me a second here. You know I'm running out of space on my hard drive from all these freaking videos. I have a 500 gig hard drive, and it's really not good at all. I only have 500 gigabytes. I understand it's not as high. It's not an SSD drive. It's not super fast. It's just a standard old SATA2 disk drive. You know, moving parts. But I'm running out of space. I have like 4 gigabytes left of space out of all of that. So just figured I'd let you guys know. Boom, boom, boom. Okay. All right. So let's go over why I knew to put iEntity here. iEntity is actually located, it's an interface. That's why it has an I before it. Cryengine decided this is an interface, so why don't we just put an I to let us know during coding that it's an interface. That's just why they put I there. And they just chose to call it entity. And what this is not only it's a type like int, string, it's also a class, or in this case, it's a struct. The exact same thing. Difference is, a struct is by default has public access. Anybody in any file and code can access all of its functions. And a class is private by default, meaning you can't, if you're not part of its class, you can't call any of the functions that's inside of it, unless you define, hey, this is public. You know what I'm saying? So this is a struct, so we can, access any function that's in this class, any variable that's in this class, because it's a struct, it's public. But it's also a type. A class is not only a class, it defines a whole bunch of variables and functions that it has, but it's also a type. So let's look at this I entity and where we can find it. It's an interface. See, I is an interface. So a good clue to find where the interfaces are, these I things, is look in the Crycommon. So let's go to the Crycommon project, and these are all the interfaces, all of the pre-existing functions, variables, stuff like that. Let's just scroll down for the I's. Let's see if you can find I entity. Let's see if we can find it. Actually, here, I entity system. I entity system. We included the I entity system. That's what it is. So let's look for the I entity system. I entity system. What do you know? Let's click on it. Here we go. This is Cryengine's own file that has, I'll show you if you don't believe me. See this function? Find entity by name. Remember, it was inside of the I entity system, right? This function was inside the I entity system, and this I entity system was inside our system, and this system was inside of our global environment. Well, the reason why we're able to call this find entity by name function is because we took use of the I entity system. So let's go to the I entity system.h here, and let's look down. Let's go to the global scope, and let's go into I entity, because it's the I entity struct. So we found the I entity. I entity. See, struct. I entity. Right here, they don't see how it says struct I entity, right? And then a colon, that's declaring. Remember I talked to you about declaring, saying, hey, there's going to be a deal called I entity. That's what this is doing. So let's right click and on this I entity and find its definition. What does it do? So let's go to definition. Blah blah blah. Actually, that didn't work. But let's go down. Actually, hold on. My bad. I entity system. Boop. See if we can find it. Where the f are you? Hold on. Just give me a second here. Oh, okay. Here we go. We found it. Oh, Lord. Pretty cool. Pretty cool. So in the I entity system that Cryengine had, we found a function called, of type I entity, find entity by name. And in the parameters, it takes a S, which is a string. It takes a string, entity name. Pretty cool. So let's look at what this Crytek wrote for what this function does. Right here. Finds the entity with the given name. What are the parameters or arguments, which is the stuff that's in these opening and closing parentheses of a function. That's the arguments. So what this function does is it finds the entity of the given name. What are the arguments? Is the string entity name to look for. In our case, remember we put on our find entity name, we put game camera, so it finds our entity that's named game camera. And then what does it return? It returns the entity. If it found an entity that you told it to get, if it found the game camera entity, it returns it. If it doesn't find it, it just returns 0. It failed. Simple. So, even though the documentation isn't complete inside of, the free SDK, all of these Crytek files here in the Crycommon and Cryaction, in this case, INT system, they actually explain quite a bit of stuff. So that's how I knew to use this find entity by name function, because I looked in these, things here, and I said, oh, entity system. I'm trying to do stuff with the entity, and this has a file called iEntitySystem, so let me look in there to see what functions they have. And then I found this. I found find entity by name. Oh, okay, I can use that? Awesome. But if I try to use it, right, find entity by name, let's go ahead. Let's try to use this. Right, find entity by name. Let's see if that function works. Find, right, find entity by name. Oh, crap. Oh, Lord. Let's hover over it. Why am I getting an error? Identifier find entity by name is undefined. It doesn't even know what we're talking about. It doesn't know what we are talking about. Well, of course it doesn't, because this entity system is inside of a class. It's inside of a class. Let's see. Let's scroll up to see what class is inside. It's inside of the struct, which is a class. I call it class, but it's a struct inside of a struct called entity system. So wait. It's inside of a class, so I really can't access it whatsoever? Of course not, because it's inside of a class. It belongs to something. You can't call a function, because by not putting anything before find entity name, it's assuming that this function is just out in the open. This find entity by name function is out in the open, and it's not. That's why it can't find it, because it's looking somewhere in the global namespace. It's looking somewhere where this function exists, and it doesn't. It only exists inside of a class. So we needed to say, hey, this is the class that it's in, and this is the function that we use that's in this class. So that's what we do. In order to use this function, we need to tell it what class is it in. It's in the entity system class. So that's what all these pointers and pointer stuff is all about. It's about finding the class that it belongs to and then calling that function that was inside that class. That's why I put that as an example, because you couldn't call that function just right off the bat, and that's what this stuff does. Okay? It gets the class, and then you can use that class, right, to call the function that's inside of it. That's why this right here works. This find entity by name works. You saw it, because it now knows what class it belongs to. See? Very, very simple. Pretty much, if you want to find a class, and I'm just going to tell you straight out, pretty much, you always use the global environment, because pretty much everything belongs to the global environment, pretty much. So if you want to find a class, and I'm going to, I cheated a little bit. Sometimes I didn't even know what the fuck I was looking for, so I sat there and I just went like this. Ready? G, capital E, N, V, line, dash, greater than symbol, and I did this. I got the code hints. I'm a little cheat. I got the code hints. And I just sat here and literally for hours checked each of these out and see what functions they had, to be honest. So what I did was a global environment, right? I wanted to call the entity system, a function that's inside of the entity system class, right? So I wanted to find the entity class. So I created a variable that will hold the entity class. I created a variable that will hold the location of the entity system. Because if you don't know what pointers are, that's why this multiplication. It's not a regular variable. See, I keep saying variable, but it's actually a pointer. If you don't know what pointers are, that was another reason why I was so difficult in understanding what Cryengine was about, because I didn't understand pointers. But I've got a good hold on what pointers are now. Still no expert. But a pointer, it doesn't really have a value per se, but it points to something. Like this find entity by name right here. The find entity by name here, the value that's coming out of this, which is called the return value, the value that's coming out of this is being assigned to p entity. What's actually happening is this p entity variable is actually pointing to, it's not saying, hey, I have this value. It's saying, I know where it is, and let me get it for you. That's what a pointer is. A pointer basically says, hey, I don't hold anything specific, but I tell you where it is, where this value is. So that's what a pointer does. to be quite honest. That's what a pointer does. So global environment, and I just went through here, and let's see. Let me show you something cool. Okay. See how this line is really, really long? Global environment, P system, get iEntity system, find entity by name. And because this find entity by name is located inside of the iEntity system, after I do global environment right here, and I get the code hints, if you look through here, I got P entity system. So I could have avoided all that by doing that. And then I could have done this. Boom. This will let me see the functions that's in the entity system. So if you remember about pointers, this isn't the entity system per se. This is a pointer. See, P, entity system. That's how you know it's a pointer, because they have the lowercase p in front of it. That's how you know if something's a pointer, because of the lowercase p. So this isn't the entity system, but this says, hey, I know where the entity system is. Do you want me to get it? Of course. So we have the global environment, right? And it's the global environment. That's what this little thing here in here is called. When you're talking about pointers, you use the dash and then the greater than symbol instead of a colon or a dot. You use these when you're talking about, if you want to call functions and stuff like that, you use the dash and then this right here, this greater than symbol. And this says, okay, I'm a pointer, I'm pointing to the entity system. And the entity system says, hey, I'm a pointer, let me point to a function that the entity system has. And these are all the entity systems. So let me find entity by name. Let me see if I can find that. Find entity by freaking name. What do you know? If I open up the because the function needs the opening and closing parentheses, I just started it and it gave me a code hint. It takes a constant character S entity name. Constant character S entity name. If you see a lowercase s in front of something, it usually means it's a string. It usually means that it takes like this value here, a string, opening and closing quotation marks. It's a string, and then you go ahead and close it. So what do you freaking know? This doesn't give me an error, and neither does this. This is a long list of deals that can get confusing. This does the exact same thing. Well, first of all, I have to assign this to a value, so it actually... Okay, now they're the same thing. Let me just make a different variable so it's not confusing. There we go. Two different things. I'm creating a variable or a pointer called iEntity. I'm creating a pointer called entity of type iEntity, and then I'm using the global environment to find the pointer to the entity system. In this case, this pointer finds the entity system, and then the entity system is calling its own function that it has. Remember, the iEntity system has a function called find entity by name, and it's of type iEntity. So this global environment, and see this right here? See the structure, iEntity system? That's what this global environment is, and that's what the entity system is. They're all just structures. So this struct is pointing to, another struct of iEntity, and this iEntity system struct is pointing to a function that it has. Very simple. And you may ask yourself, why didn't he just write this smaller line of code in the first place? That is a good question. To be honest, I didn't look. I could have written it just like this. Global environment P system, get iEntity system. I could have, written it just like this. It's a lot smaller, but at the time, involved in understanding understanding it, trying to understand it, so I didn't really realize I can just shorten it up. But essentially, it's the same thing. You can write it either way. This is just a shorter way of finding it. Just like that. Pretty cool. So that's how we use pointers. Pointers point to things. What do you know? Pointers point to things. Exactly. So that's what all these things do. That's how we can use these functions. This function, find entity by name, this function create view, this function get view ID, and then what view ID to get, and this set active view, and then the view that it wants to set as active. These functions exist. All these pointer stuff, which is more the confusing stuff, is just telling it which class this function belongs to with pointers. That's all. This pointer's right here. So like I said, this pointer is pointing to this pointer is pointing to this pointer is pointing to this, on and on and on. And then finally, we have the function that we want to use. This function belongs to the iEntity system. See? Function belongs to the iEntity system, this structure, this class. And this class belongs to the just system, right? This class is basically derived from the system class, and the system class is basically derived from the global environment. Because you guys know about deriving classes, right? If you guys are into C++, you know about deriving. You have a class, and then you can derive a new class out of that class, and then derive a new class out of that class. That's what this is. You have a base class of global environment that pretty much everything starts with. Then you have the P system, which is a pointer to the system class. And then you have the system class, which is pointing to the, the P system has a function called get iEntity system, which gets the iEntity system. And then the iEntity system has a function called this. I can't make it much more clear than that. You guys should clearly have an understanding, definitely better understanding about how to program in C++ with Cryengine. Better than you did. I'm pretty sure I did a good job. But there are a lot of stuff that I could basically, to be honest, to people who already know programming, I look like a freaking idiot. They'll probably sit there all day long and say, well, he got this wrong. It's really not called this. It's called this. I'm damn well sure of it because I am not a programmer. I'm getting there, but can't really quite call myself a programmer. So I'm pretty sure I'll have some comments saying I did this wrong, and please do tell me so I can learn. But the basic line is, this code works, so I'm doing something right. I'm teaching you something right. So I'm glad I can help you out, and that is how you write your own, create your own files, create your own functions, create your own variables. Then how to call your variables, where to put your code. Code goes into the game.cpp file, right? And we put our code in the update function because we know the update function of our game gets run every single time. So every single frame, our function create RTS camera is going to be done. And I really honestly need to put that some handling on when to do it. Because let me tell you this, that code right there was pretty bad code. Because that update function gets run every single freaking frame. That means, because we're calling that function, and every single time that new frame happens, basically every millisecond or 2 milliseconds, or depending how fast your system is, this function is being called. And you can imagine that after like 10 seconds, I have 1,000 cameras that were made. Why do I have 1,000 cameras? Because this function creates a camera. And if it's getting run every single frame, I'm going to have a new camera every single frame. So by the time, let's say an hour into playing my game or having my game run, I'm going to have like 1 million freaking cameras. And that's not good. So that's why I implemented this B is level loaded. Because in my game, I check, is my level loaded? And if it is loaded, if the level just got done loading, then create the camera. And see, if is level loaded equals true, that means it's going to create it. But next time it comes around, after it does the next update, that's going to say, hey, we've already created this, we've already done this, don't do this, and just go on. That's why I have the is level loaded. I created a function that checks if it's already done once. First of all, it checks, hey, only do this function if my level is loaded. Secondly, after it's loaded, set this variable to false. Is level loaded equals true. Then do this. But after it's done this, then done this, the next time it comes around, it won't do this. Why? Because after the function's done, I changed the thing to false. So this will never do. So I've actually changed it so that with this is level loaded function that I created, see? Is level loaded declaration, is level loaded definition. I've created it to only do it once, and that's it. But we didn't go over this in this tutorial. We will go over that later on. But that is how you do it in C++. You guys will have a clearer understanding, and trust me, with my RTS, how to create an RTS game from start to finish in Cryengine, we will be doing a lot of RTS. We'll go into a whole crap load of stuff. I mean, now that I really know how to use Cryengine C++, I'm going to be doing it quite a bit now, learning as I go. And I'm so freaking excited. Extremely, extremely excited that I finally learned how to use Cryengine C++. Now there's no limits to what I can create. I just want to take a second to really thank Crytek for the great engine that, it's just amazing. Anything else doesn't really compare to it. It's just absolutely amazing. Thanks for including the source code for the game. That's a big, huge plus, and I'm pretty sure all of you guys agree that Crytek did a really good job, for free, releasing their engine for free, and allowing us to actually go commercial with it. With a small, a fee, of course, but it's just this opportunity that we get as creators and making our own games and designs, and just maybe not even a game, just playing around, fiddling with it, making something new, making an experience. It's just amazing that we have this opportunity thanks to Crytek. Well, this is the end of my tutorial. I just walked you through how to create your own custom files, how to create your declarations of functions, how to define your functions, how to call your functions, where you call your functions, what files are important, where you start to write your code. Bingo. It's all of it, right? Where to find existing functions, which is in the cry common and cry action. See? Cry common, cry action, cry common. If you look through these files, and you'll find different functions that you have access to. And now you'll know how to actually call a function. So, thank you guys very much for looking, and I really hope you like this tutorial. I do, really, really do. I hope you guys like this tutorial. If you have any comments, just let me know. If I did good or bad, please definitely comment rate. And if you like it, let me know. Hey, wow, you're the first one on the internet to do a C++ tutorial. You're the fucking best. I love that. Or, if on the opposite side, if you want to say, hey, you're a stupid idiot, why don't you get a real job or something, then, go ahead, write that. But either way, thank you guys very much, and I appreciate it. And sorry for taking so long, but if you want to offer good material, sometimes you need to be out for a while to study yourself. Thank you very much.